Hello, let's do leetcode speedrun now. So we will be solving mostly easy problems, and yeah, let's start with the reverse string. So write a function to reverse string. The input string is a character. You must do this by modifying in place with one extra memory. So we have this string, and if we have to do it in place, we can do it by having two pointers left and right, and we swap numbers. We move pointers to the center, we swap numbers again, and then when pointers become the same, we break the cycle. So for example, I have a left-right pointer, which is 0 and length of our string, while left then less than right, we do swap, meaning string left string right equal string right string left, and we return string. Index out of range. So, oh yeah, we have to move string len -1, and we have to, on vary, we have to increase left pointer degrees, right pointer. That's important. Yeah, perfect. Let's move next. Remove all adjusted duplicates in a string. If you're given string consists lowercase English letter, duplicate removal consists of choosing two adjacent and equal letters and removing them. Adjacent and equal. We repeatedly make duplicate removal until we no longer care. It was the final string when such duplicate removals have been made. It can be proven that the answer is unique. So CA. Well, for example, Abaka, we could remove BB since the two letters are adjusted or equal, then it is not possible to move. Then we remove AA. Oh, okay, so we remove after. Okay, so one way to do it is brute force solution, right? We check. We run through the string every time. If we found two adjacent, we remove them, then we run again, until no adjacent strings in there. Then we just return the string, right? So this is brute force approach, and it's quadratic time complexity quadratic, which is not good. So let's think of better way. Better way could be stack. If we would add this to a stack, right? So we add first letter to a stack. We move next. If stack is the same, if not the same, we add another one. We go to this one. If stack is the same, we pops from the stack, we remove letter. We go to next one. We check with the stack, we remove next one, and we return whatever is left in the stack. So it will be better. It's all n complexity. So yeah, brute force is consistent iteration while over array and removing, which is quadratic equation, and square. But this could give us all of n complexity, which is much better. So let's write it, how we gonna do it. So first step, we if stack is we add first element first element into the stack. Then next step we check if current pointer. So we're gonna have pointer on string, or like current element of the string. Current element of the string. Is it called like pointer? Is it better to call it pointer on the string, or current element in the string? Or what we can say, we iterate string, right? Iterate string. Add first element into the stack. It's probably gonna be like this. Check if current element not equals stack. Answer step, right? If does, we pop the stack. If not, else we add element to a stack. And at the end, we return stack. Yeah, so let's quickly do it. C in as character in string, we declare stack with yeah, we can do this. We can declare stack, and we can say if stack and stack -1 equals C, then what we're gonna do? We're gonna stack pop, else we gonna stack append character, right? And we return whatever we have in stack. Do we have to return string? Yes. So we join stack, right? Simple enough. Stack. Oh yeah. So sorry about that. It's st. Yep, it's passed. Next, valid palindrome. A phrase is a palindrome if, after recovering all uppercase letters into lowercase letters and removing all non-alphabetic character, it reads the same total setback. So this is the same like reversing string thing. So we will remove all characters and yep. So I would remove on the first pass. Do we have any restrictions? Only a ski chapters. Okay. Printable as key. So Python remove all non-alphanumeric, stripping that alphanumeric from the string. Whoa. There is a alpha ASCII letters like, wait, ASCII letters, it's a yeah, I like this one. So ASCII letters is a constant into Python, so we can use it. Yeah, let's do this. So we have a strip. We don't need digits. And what we gonna do, and we also, it's nice to have a list So we have a list from, let's do this. Yeah. So what we're gonna do first, we're gonna, let's write it in English first. We're gonna strip non-alpha chars characters and strip non-alpha characters. Then second, we have left and right pointers as with 0 and len of the string. Then while we do the same technique we did for reversing the string. So while left less than right, what we're gonna do, we're gonna if a character strip non-alpha character, so we have C equal that thing. In ASCII letters, right? But does ASCII letters include, let's do print now. Does ASCII letters include, I don't know if ASCII letters in Python including space and comma, for example. It does not, which is very nice, but we have to do lower, right? Lower. Oops, my bad. Typo. Perfect. This is what we need, exactly. So, yeah, and we have 2 pointers, and if characters in left pointer not equal whatever we have in right pointer, we return false, and at the end, we return true. So it's pretty straightforward and easy, although, so let's go and implement it really quick. Then it print, we have left and right pointer, and we have to lens character while, and here also we have to increase left pointer, decrease right pointer, and yeah, basically that's it. Let's give it a try. So C is not defined. Why C is not defined? Because I mistyped it. I have to somehow like train my typing skills because okay, C out of range, because this is must be -1. And thinking skills. Yeah, submit. Let's go. Oh, wrong answer. Nice. Okay, so why this is wrong answer? Because of 0p, and it's returned true. Wait a second, this is like impossible thing. So 0p. And same palindrome. Because left equals 0. Oh yeah. So the thing is, if length is just 2 character, if len is 1 character, right? So what we can do, we can say L equal length of C -1, right? Okay, and so like this. Now we can say if len equal 1, meaning we return true. We don't need all the thing. And if len L equal 2, we return C0 equals Cn, C1. That's it. It may be something wrong here, but I don't want to go through it and figure out why. Its corner cases is not processed, so still. Okay, let's do this. Let's, why 0p? Oh, because this is like, but we ignore numbers. We ignore numbers. Non-alphanumeric, alpha numeric. Okay, here we go. Okay, so we have to do numeric. Okay, let's do digits then. Yeah, I misread the thing. Yeah, so we do alphas, ASCII letters and digits, and run through that. Yep. Here we go, 82%. I'll take it. Next one, make a string great. Given a string of lower and uppercase English, a good string is string which letter doesn't have to adjust the character where. So we have leet code. The first step is to choose e equal 1 or equal to birth result to be reduced to leet code. What? Okay. You can choose two adjacent characters that make the string bad and remove them. Two adjacent characters. So B and B adjacent, we remove them. Oh, this is the same that we have with the stack. Isn't the same? Kind of the same. I like. Didn't we solve it again already? Maybe no. Okay, so this is the same, similar that we solved previously at the beginning of the video. So what we're gonna do, we have first we have brute force solution, right? When we run through and remove two adjacent character, but this is two adjacent too. Why we didn't remove them? Is a lowercase in the same letters, but uppercase. Okay, and vice versa. Okay, so we can remove only lower. We can. Oh yeah, it's just variation. Yeah, so we remove CC to AB. We remove AB. Then we remove AA. Then we remove CC in equals empty. All right. Yeah. So brute force solution, we go through the array multiple times and we check if two characters are ugly and we remove them if they are. And then we iterate until we cannot find ugliness anymore, and then we return the string. This is quadratic time complexity. We're not going to do it because it's boring. More interesting thing if we use stack and like we have similar task. And in that task, we add so in that task, we did following. We created stack and we iterate string if stack and character in the stack equal whatever we have current character. So this will be our current character in string. If it is, so we cannot compare like this. We need to say like we need to compare in a way such if stack, so there is something in stack. What we're gonna do, we're gonna if our C is upper, then we have to check and stack -1 is lower, then we, or vice versa. I don't know how to, is there a smart way like to compare, to detect this ugliness? So is lower and is upper. So we have to, so first we have to detect that. So if this is exist into stack, we pop the stack. So we do stack pop, and that's it. Other else we add stack append whatever character we have. The only thing is this ugliness detection. Yeah, we can tune it as we go, but basically we have a function. We could have a function or part of functionality that detects ugliness and remove it from the string. So string would be great, right? What is opposite of great? I don't know. If something is great antonym. Opposite is minor, or not a good word. Lacking. Majestic. Okay. Oh, modest. Okay, modest. Modest is a good word. So if this is modest, if we detect that two characters are modest, we remove it. So it will be great. All right, let's quickly implement it. Yeah, and at the end we remove, we do stack whatever we have in stack, we will just join it and we return it. And this gives us like brute force will be quadratic time complexity. This will be of n because we're doing just one pass through the string, and yeah. So we declare stack, we iterate for C in string. If we have a stack, I'm not sure about this upper and lower, and so I can say modest, and we see, and we compare C and stack -1, then we pop, and at the end we return the same. Right? Let's define modest. So we have character 1 and character 2. First, they have to be opposite case. Same character of opposite case. Same chars of opposite case. So I can say if C1 to lower and equals C2 to lower, so they are opposite, right? They're the same, but opposite case. How you can say that they're opposite case? Is upper in I don't know. There is a function is upper that returns that this is the up case. Should we ask ChatGPT? Let's see. So how to check if char is uppercase. Yep, is upper. Oh, perfect. Yeah, so this is what we need. And we say and C1 is upper. So this is the first condition that we have to make. And then is upper and C2 is lower. Right? Or vice versa. Lower and C2 is upper. So if this is the same, if this condition is met, it's modest, return. So we can say if modest, then we pop. If not, we append and we return. I think it's very nice. How in Python multi-line zero-line condition in Python? Okay, multi-line condition is fine. It's kind of like a little bit ugly. So if condition and condition, oh, okay. This is nice. Yes, I like it. I like this, but this is no, I don't like this. I don't know. It's like personal preference, I guess, but I don't like this. You can drop entire condition parentheses, which allow you to split it across lines without needing a backslash. Yeah, perfect. Oh, yeah, let's try it. So we can say nah. Yeah, let's add a backslash here. I know it's like not good, but still at least something. Bring a little bit more greatness to our code, right? It's less modest, but much greater. Yeah, I'm approving one more valid parenthesis. Okay, so here we go. Yeah, this is kind of nice. And we have to add like one more parenthesis to close the entire thing, no? Unexpected character. All right. Okay, so how about we say same. Yeah, I probably spending too much time on getting like all this beauty and to my bring all this beauty to my modest code. Let's have this and okay, too much. Same and we can say diff case, so they are in different case. We can say like here. Right. So if this is upper, lower, upper, and the lower upper, right? And then we need one more. Do we need one? No, we don't need one. And we can say if they're same in diff case, we return. Yep, but this is not working. Why? Because it's returning only one check. Okay, if this is the same and we pop else, we add if stack and modest. Yep. Perfect. Yeah, we can say that this is kind of expensive operation, right? So we can say if not same, return false. Still 18%. Okay, let's see how it's fast. Ord minus equals 32. Oh, okay, yeah. So if the difference is 32, I see the beauty. So difference between is exactly 32. Yeah, that's much better, I agree. But that's okay, I will take it. And another binary, I'll try to solve this binary thing and see if it beats medium, but let's try. Given binary string s and positive integer and return if the binary representation of all integer in a range are substring of s or false otherwise. So what we can do, there is a binary function that will return yeah, are we allowed to use binary functions that will return binary representation of n, right? Probably we are. Do we expect to convert it manually? So what I can do, I can return in one string if s index of bin n more than 0. That's it. Substring not found. Okay, so substring index of bin query. What? Runtime error. Substring not found. Index query string. Oh, 0b. We have to remove 0b, right? We replace 0. It's I don't know. It's like, are we allowed to do this, or interviewer will be like, oh no, you have to convert it everything manually. So 11 is in here. So let's do str string to find, and then we can say string to find. Oh, it's not index, it's like how to find substring. In operation. Yeah. Nice. So we return if string to find in string. Okay. I don't know. Like, I mean, oh, that's interesting. Okay, one answer. Why is such a wrong answer? So we print string to find and we print string. Okay, a substring contains a character with a string. A binary representation of all integer from 1 to n are substring. Okay. So this is a function for in range n. So it's called function def. Let's call it b in and we accept number, right? Number, and then we did this number and we return this. Yeah, so in this case I misunderstood the problem, but in this case we go for square complexity because for every n we search in a string which is of n and we have a square complexity, right? But how this works, I wonder. Oh, okay. I understand why. Okay, so let's try this. It may not work, but let's give it a try. So we say if being in, if not binary in, we return false immediately, and then at the end we return true right away. Yeah, it's quadratic complexity, not good. Oh yeah, so we have to recounting from 1 to n. So we start from 1, we end it by n. Should I do n plus 1 in this case? Probably. Yeah, it accepted, which is a good thing. But I bet there is a clever way to do it. I mean, like, because when we represent a binary string like this, there are parts of the string that already there and we don't have to research them, like search again. So for example, if we have So classic binary representation, we have 32, 16, 8, 4, 2, 1, 0. And for example, if we have a 15, right? So we start from 0, 0 is there, obviously. If string contains 0, no, we don't need 0, okay? Because we start from 1. So 1 is obviously there, right? 1 is there. Then 1, 1, which is 2, is there. So how about we start from the back and check on more complex numbers first, right? So we start with n minus 1 minus 1. Minus 1, and we end with 0. Wait, this is the beginning, this is the end, right? So we start with more complex pattern first, and then we go to easiest pattern, because the probability is at the 100%. Wow, bravissimo. So yeah, because you see, if we have a 16 number, it's more complex pattern, right? It's 0, 1, 1. And we have to make sure that this pattern already exists in our string. If it's not, there is no game. So yeah, I think this is good enough. But yeah, let's see how people solve it. There is no. Oh yeah, okay, binary representation, low, remove. Yeah, it's backwards checking. But why do we need this? The whole thing? Beat, flag, true? I don't know. Oh, we are searching for beats instead of. Okay. I still don't understand how it works, but it looks cool. And it's far from elegant. Let's see what people does. This guy is like killing it. Oh yeah, this is what I did. Oh, solution to continue to improve about solution OS. 2 passes in rolling hash. Wow. Okay, but I think it's good for today, and thank you for watching. See you next time. Bye.